Hey, you guys, Mrs. Morell here with your warm-up question explanation for the week. I apologize that this is just now getting posted. I didn't realize it hadn't been done. So here we go. Monday, Tuesday warm-up questions, March 29th through 30th, were super easy, just to kind of reiterate the information that we've been covering. So we'll start with number one. How do sandy beaches form? Well, beaches form because of weathering, erosion, and deposition. So you could make a case for all of these answer choices, but I think the question means in general, how do sandy beaches form? And they form by the repetitive action of waves upon rocks and pebbles on the beach, weathering them into smaller and smaller and smaller pieces. And that's where the sand comes from. So the answer was A. It's also really cool because that's where black sand beaches come from. The kind of rock is different. It's igneous rock, which is volcanic rock. So like in Hawaii and places in the Pacific that are real tectonically active with volcanoes, you get black sandy beaches. And that's why, because it's weathering of black igneous rock. Just fun fact. All right. What type of changes does erosion cause? Well, the definition of erosion is moving sediment. That's the material after it's weathered. It's weathered down into sediment from one place to another. And moving material is just a physical change. It's changing the location. Might change the shape of a barrier island or a beach or a riverbed, but that's still a physical change. It's the way it looks. All right, number 3. What is weathering? Weathering is the process that breaks down rock, which is Earth's crust made of rock, the crustal layer, into smaller pieces. There are 2 kinds of weathering. There's chemical weathering and physical weathering. Physical weathering is by wind, by rain, by ice, the action of wind and water. For water, whether it's rain or ice, that's physical weathering. Chemical weathering is the result of chemical reactions. And some of those reactions might be acid rain falling on material, which can cause chemical weathering. Another is interaction with, if it's very reactive with oxygen, that can cause chemical weathering. But chemical weathering, just like a chemical change, is the result of a chemical process. A chemical change has occurred. The chemical composition has changed. So number 3 is A, a process that breaks down rocks into smaller pieces. Number 4, the dropping off the sediment into new locations. And that is, the root word is deposit. That is C, deposition. So weathering breaks it down, erosion moves it, deposition is where it stops moving. It's deposited. I don't know what Fortnite has to do with any of this. Number 5, why is it hard to see glacial erosion in action? Well, it's hard to see glacial erosion happening in front of you because glaciers move very, very slowly. So a lot of times you need like a time-lapse camera. You need time-lapse photography to see glaciers move. This week we looked at Google Earth before and after satellite images of several glaciers over the course of years and could see how they've been reduced, how they've melted. Those before and after pictures, but it would have been hard to see that if you were just standing there watching the glacier because it happens relatively slowly, although it is accelerating due to climate change. All right, so there are the first 5. Let's go to the second 5 now. All right, here are the questions for Wednesday, Thursday. The Piney Woods ecoregion in Texas receives more than 50 inches of rain each year and is home to many different species of plants and trees. Knowing this, what can you determine is true about erosion within this particular region? So the key words here are many plants and trees. When we went out into the courtyard, or hopefully if you're at home, you watched the video of the stream table where we modeled weathering, erosion, deposition. And one of the things we talked about was that if we want to reduce weathering and erosion on our coastlines and our riverbanks, we need to plant more plants because the roots of the plants hold the soil in place. And that really reduces the erosion that puts all that nasty sediment into the water. And you'll remember back from succession that secondary succession, which is what happens when soil is left, the pioneer species is grass. And part of the reason for that is grass holds the soil in place. So the key points from this question are that the piney woods have lots of plants and trees. So if you know that they have less erosion than a place that doesn't have a lot of plants and trees. So the best answer is soil erosion is minimal in this region due to all the vegetation ground cover. So the answer to number 1 is B. Number 2, which of the following describes an impact of floods in an ecosystem? So this one you had to kind of think through a little bit. First, you can eliminate A because strong winds don't necessarily have anything to do with floods. It's the water current that uproots the small plants and trees. But keep in mind, the small trees and plants have been uprooted and carried downstream, and the stream ecosystem itself, or river ecosystem itself, has been damaged. So soil erosion along rivers that prevents plants from getting sunlight, that could absolutely be the answer. But let's keep going. Homes that are destroyed and people getting injured. Yes, that is a thing that absolutely happens, but we don't really consider those ecosystems. So we're talking more of the natural world. So we can eliminate A and C so far. Less competition for space and resources among aquatic organisms. Well, if the plants and trees have been uprooted and carried downstream and the stream structure itself has been damaged, haven't we reduced the number of resources available? So that means there would be more competition for resources. So it can't be D because it would have more competition. But answer choice B, soil erosion along rivers that prevents plants from getting sunlight because the plants have been disrupted. They've been uprooted. They are no longer functioning. They're no longer photosynthetic. And all that erosion in the water keeps the water plants from getting the sunlight. We talked about that when we did the stream table. So the best answer for number 2 is B. Number 3, a student with a bird bath made of poured concrete. When she bought it, the salesperson suggested that she seal the surface with a watertight solution. Why was this suggestion made? This suggestion was made. The watertight solution keeps water from soaking down into the concrete. We want to do that because in cold, wet weather, any water that's in the concrete could freeze and then frozen water expands. It would crack the bird bath, and so it would no longer hold water. So you want to coat it with a watertight solution to keep the water from soaking into the concrete. Number 4, how is mechanical weathering different from chemical weathering? Well, we talked about this just a second ago. Mechanical weathering is a physical change, and chemical weathering is a chemical change. So you need an answer that says that, and that is D. Chemical weathering changes the chemical composition of materials, and mechanical weathering does not. And number 5, again, which term best describes the rate at which glacial erosion takes place? And that is also slow, because erosion due to glaciers, because glaciers move slowly, the erosion is slow also. All right, so hope that helps. If you have any questions, see your science teacher. Have a great weekend. Oh, and sorry for the delay.